Welcome back to another exciting day of mathematics. Woo, woo. How's everybody doing? Good? All right, warm-up 14's on the screen. Let's get started, please. Today, for the sake of time, we're not going to be on our Chromebooks. Today's going to be old school, paper and pencil, or rock and chisel, whatever you want to call it. Yeah, like we're going to be like carving into our rocks. So, stay focused, please. You will need a calculator, so make sure send a gopher. Oh, you should be done by now. So, first thing we do when we have data, tell your neighbor what to do when we have data. All right, ascending order, that is correct. 85, 90, 100, 100, 100. Next, we find the mean. So, 100 plus 100 plus 100 is 300 plus 90, 390 plus 85, that's 475. And we divide by how many numbers? 5. So, 475 divided by 5, that is 95. Oh yeah, I'm going to get a shirt that says no calculators needed. About 10 apples. All right, next, what do? We subtract from each of these numbers the mean. For each of these, subtract the mean. Notice that I'm saving space by not rewriting those numbers with a subtraction. I'm just subtracting straight up right there. So, what do we get? This is negative 10. We're going to write that squared. This is negative 5. Write that squared. This is 5 squared. 5 squared. And 5 squared. So, 10 squared is 100. These are 25, 25, 25, and 25. Are we doing yes? What do we do next? We find the second mean, Mr. Q. All right, so that is 25 plus 25 plus 25 plus 25 plus 100. That's 200 divided by 5. That is it 40? All right, 40. And are we done? No, at the end we need to find our sigma or our standard deviation. So what is 40? Take the square root of 40. Calculators. 6.32 approximately. All right? How are we doing with that process? A little bit better, yes? Because this is going to be our bread and butter all year. So make sure you get acquainted with the process. Okay? All right, copy the agenda, please. Warm-up 14 done. Standard deviation and normal curve. Home plate for tonight, 2 problems for standard deviation. And you're going to graph a bell curve. All right, copy this code for home plate access. HRZX9. 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 All right? So, previous home play, that was Thursday. You did standard deviation. Tonight's looks like this. All right? Now, before we get a Cornell note going, look up. Very important. What did I ask you to bring today? Tell your neighbor, what did I ask you to bring today? So, get your Chromebooks out, go to Canvas, turn in your signed progress. It counts as a pop party. You got that, Camila? All right, here we go. I can compute the standard deviation of data and represent on a normal curve. Write that down. Today you don't need a big box or the Ferrier model, just copy the objective. I can compute the standard deviation of data and represent on a normal curve. Now I'm going, like I said, slowly but surely. Today we still are not full on standard deviation. I'm just adding little layers to it, little by little. We already know how to do the process to find it. Today we're going to apply it to a word problem and go to graph it. Okay? So once again, I can compute the standard deviation of the data and represent on a normal curve. So our standard for today is standard deviation, or our concept for today. What are we doing? We're computing and representing. Okay? So, first of all, let's break down the word standard, or the concept standard deviation, the term. Last week we did the processes. We got that. So on your paper, in blue, write standard. In red, write deviation. Standard deviation. And say it again. You don't need a Ferrier model, no. So, I like to clarify the terminology just to make sure it makes sense to me. So if that makes sense to me, it should make sense to you. So, before anything, think about the word standard. Think about it, standard. All right, share with your neighbor what comes to mind when you say the standard. This is the standard. Yeah, I heard a baseline or a bar to follow. Kind of like in this class, my classroom all years, one of the standards is that you respect everyone and everything in this class. So that's the standard. That's what I'm going to ask from everyone. So therefore, definition for standard. So to the left, I want you to box it and write something established as common or custom. A standard is something established as common or custom. Something established as common or custom. So once again, in this class, respect everyone and everything, that's our standard. Now, does everybody follow the standard? No, that's what we call deviation. Deviation is when someone is not on the standard. So, in red, write this down, departure from established custom. Departure from established custom. Kind of like, I know which one's like the doozy. School zone speed limit here is 25 miles an hour. That's the standard. Now think about some of y'all, or some of y'all parents, when they're driving to here in the morning. Like today, I felt like, I literally felt wind passed me by. When a vehicle passed by, I was like, what the heck? They were going at least 45 just to get to the stop right there to turn into the parking lot. Really? Wow. So anyway, speed limit should be a standard, yes. Anything above or below the speed limit is called what? Deviation. You got that? Yeah? All right. Underneath here, look up. Underneath where you wrote this, you're going to draw a graph that looks like this. Draw that right underneath where you have your terminology. Center it as much as possible. And, yeah, make it maybe 4 or 5 lines worth. All right, and quick introduction, students, bell curve students. Nice to meet you. Now, why do you think they call it a bell curve? Right? Pretty straightforward, huh? Lolly. Pretty straightforward why they call it a bell curve? All right, good. All right, with that said, I'm going to show you how to build a bell curve because we're going to need that to show our standard deviation. Here we go. First things first, we need a line straight down the middle, like so. And I'm going to label that X bar. Tell your neighbor what that means. Get it? Tell your neighbor what that means. Yeah, the mean. There you go. So, whenever you are building a bell curve, look up, please. When you go straight down the middle, this is what we call the standard. The standard is the mean. The standard is the mean. Now, some are going to go above or below the standard. So watch. I'm going to have a space here and draw a line down above. And then another space to the left and a line below. This is what we call going up 1 standard deviation or down 1 standard deviation. Now, most data or statistics, particularly in college, when you hear professors that are saying, we're going to grade by the curve, this is what they mean. Okay? What they mean is this, that instead of just going with the highest score being A's, they're going to say, I'm going to go with the mean, and I'm going to go 1 standard deviation up and down, and this will be our norm. So anybody that scores within that section is okay, doing all right. How are we doing? Yes? So, let me put it in, as I started earlier with the speed from the street. If 25 miles an hour is our mean, what would be going up 1 standard deviation? What do you think would be reasonable so that somebody doesn't get a ticket from our police department? What would be? How many miles? 3? 30 miles an hour? So that's going up 5 miles an hour up. Some drive 5 miles an hour below, so 20 to 30 would be the norm. Does that make sense? Okay. So, now check this out. We need some percentages. Look up. Label this. We got 34.1 to the right of the mean and 34.1 to the left of the mean. So that means that the norm is how much total percent? 68.2%. 34 and 34 is 68. How are we doing? Good? All right. Next, draw another line to the right of that first standard deviation and another one to the left of the other standard deviation. So, check this out. So here's our mean. We go 1 up, so we label it 1 positive. We go 1 down, we label it 1 negative. So what do you think I'm going to label this one? This one would be what? 2 positive standard deviation, yes. And this one is 2 negative standard deviation. So question. Somebody said, Mr. Q, so if we go up that 30 miles right here, it's still the norm. So what would be something outside of the norm? What would be this speed limit right here? So if this is 25, this is 30, what would be this one? 35, right? And that would be one of those that the police then stops, like, we're going 35, and then all of a sudden you smile and you try to be the nicest person. Please give me a break. I totally, wasn't paying attention, blah, 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 blah. All right. What percentage is that? Write this down. 13.6 and 13.6. However, there is one more line. What would we label that, everyone? Yeah, third standard deviation or negative third standard deviation. Now, for that part, people are already in trouble. Let's see. If the mean is 25, and you guys said this is 30, and this is 35, what would be our third standard deviation? About 40, right? So, what is the percentage for that? This is 2.1, 2.1. Not a lot of people fall into that box. 2.1%. Now, do we have crazy people that drive really, really crazy? Do you think I'm going to have people driving by here at 50 miles an hour? Guess what? They fall into this little itty-bitty space over here, which is 0.2%, not even 1%. 0.2%. Very rare, yes. Oh. Trent. Let's go. Yeah, turns out, Mr. Q, where are you getting those numbers? I'm out. No calculators needed here. Let's go. But it's a good question. Look up. Turns out, like, Mr. Q, all these numbers, that's good and all, but what if I add them all? Tell your neighbor, what would I get if I add all these numbers? All right, looks like Val's got it. Very good, Val. Kayla's got it. I see you, Kayla. If we add the whole thing, what shall we get, Andrew? If we add the whole thing, what shall we get? 100% under the curve. That is correct. Everybody see that? Yes? However, look up. If the standard is the mean, how much would it be in percentage to the right? Everything to the right. Tell your neighbor. 50%. That is correct. And everything to the left, another 50. That is correct. And that's how it breaks down. Now, do I expect you to memorize this? Not right now. We're going to get to that eventually. But this is just a soft intro. All right? So, with that said, example Q. Write this down, please, underneath. Yeah, you still have space. Example Q reads, compute the standard deviation, sketch a bell curve, and conclusions. And it reads, Mr. Q asked 5 students how many hours of sleep they got last night. 4, 8, 7, 10, and 6. I'm going to give you 2 minutes so you can copy the whole thing. You do need the whole problem as an example. Write it down. Also, right before I get started with this example, this is going to go pretty quick, like I said, and hopefully it makes sense, everything that we've been working on. Do me a favor, could I get the last person on each row? Come get a handout for those in your row from over here, please. They're up here, one for each of your row. Now, what is this? And this is being recorded once again. So that you guys know, Ms. Vargas, you guys see Ms. Vargas here? Yes? We're going to be doing tag teaming with some of the lessons. And also, SDSU asked her to record herself. So this is just to let your parents know that she's going to be doing that throughout the semester. Okay? So make sure you get that filled and brought back tomorrow. Thank you. All right, here we go. Let's do this one together. It reads, Mr. Q asked 5 students how many hours of sleep they got last night. 4, 8, 7, 10, and 6. What is the first thing we do with data, people? Tell your neighbor. Ascending order, that is correct. We got 4, 6, 7, 8, and 10. Okay? What is our second step for standard deviation? What do we do next? Tell your neighbor. What do we do next? What do we do next, Sean? Very good. Find the mean. Find the mean. So, calculators calculate. 4 plus 6 plus 7 plus 8 plus 10. That gives me 35 divided by how many numbers do we have? 5. So our mean is 7. Okay. All right, remind your neighbor, what do we do next? What do we do next for the standard deviation? Yes, we subtract that from each of these numbers. And notice I just wrote minus that number right next to so I can save time. So, here we go. What is 4 minus 7? That's negative 3, and we write it to the second power. Next one, 6 minus 7 is negative 1 to the second power. 7 minus 7 is 0 to the second power. 8 minus 7 is 1 to the second power, and 10 minus 7 is 3 to the second power. So, negative 3 squared is 9. This is 1, this is 0, 1, and 9. All right? Tell your neighbor what to do next from there. What do we do next? All right, looks like Camila's got it. Very good, Camila. Let's go with Jake. What do we do next with those numbers? Find, bam, Jake in the house. Find the mean. 9 plus 1 plus 0 plus 1 plus 9, that's 20 divided by 5, so my mean is 4. Are we doing pretty good? All right. Last but not least, we need our what? Our sigma or our standard deviation. How do we find that? Tell your neighbor. Remind your neighbor. How do we find that? Yeah, square root of this number, so square root of 4 is 2. All right. So, from 1 to 5, how comfortable are you with that so far? Yeah, we got it, right? All right. Next, let's sketch a bell curve over here to the right. Nice and neat like mine, as best as possible. All right. So, what is the first line that we draw for our bell curve? Yeah, down the middle, right? And we label that the mean. And in this case, we go with the first one that we found, which was what? 7. So let's label that 7. So what does that mean, Mr. Q? Well, let me read the problem. Mr. Q asked 5 students how many hours of sleep they got. I got all these numbers and I found the mean. What does this mean? What does this mean? What does that mean? What is this number, people? Average, or the standard, yes? So, this is our average. So that means, look up, we want to find out what is the norm. So we go 1 standard deviation up, we put plus a standard deviation and minus the standard deviation. So let's see. If the mean or the standard was 7 hours of sleep, and my standard deviation, get it, deviation is 2, what number should I write going upward? Talk it over to your neighbor. What number should I write going upward? If the average was 7, the standard deviation is 2, what should I write there? Up. Up. 9, that is correct. 7 plus 2 is 9. However, some people don't go above sleeping 7 hours all the way to 9. They cut it short. So what number goes there? 5, that is correct. Now check this out. We know that those two are called our what? Our norm. So what does that mean? That the norm of sleep for the students was from 5 to what? To 9 hours. 5 to 9 hours. That make sense? Yes? Now check this out. So now let's see the numbers that were given. Here goes again. Mr. Q asked 5 students how many hours of sleep. Look at these numbers. And look what we found. Talk it over to your neighbor. Let them know, what do you see from there? What do you see from there? Talk it over to your neighbor. All right, looks like Camila's got it. Very good, Camila. Oh, you're going. My bad. You're going to the... Okay. But she left Lali in charge. All right. So, Lali. All right, here it goes. Look up to the screen. If we said that the norm or normal sleep was from what? From 5 to what? 5 to 9 hours. And these are the numbers that were given by the students. What would you report back to Mr. Q? What would you report back? Who saw that there's 3 students that are within the normal sleep? Hands if you see that. Let's see. How many hours was this one for? Nope. It doesn't fall in here. It's somewhere over here. 4. How about 8? Yes, it's somewhere in here. How about 7? Yes. How about 10? No, it's over here. How about 6? Yes. So what would I write? 3 students sleep the norm 5 to 9 hours. 10Q. Yeah, because the person with 10, they probably got home, they crashed after practice and I don't know what. And this one with 4 hours, they were on their phone all night. And they just went to bed like at 4 or 3 in the morning. All right, from 1 to 5, how comfortable are you with this so far? Where are we at? 4, 5, 4, 5. Okay, I told you guys it was going to be a little bit robust. All right, let's see how we do with another one. Here we go. Copy this one. Example Super Q. Did everybody get the statement? Yes? All right. For this one, you only copy the data. And it reads, only the data. It reads, Mr. Q Stats class part-taste scores out of 10 points were, and this is for Friday's block part-taste, 8, 8, 8, 7, 6, 7, 6, 7.5, 6.5, 7, 6, and look at this last one, 0. All right? So, Luis is very enthusiastic, and he's going to tell us what to do first. In ascending order, okay? So we're going to start with the lowest number, which is 0. From there, we go to the next one up, which is 6. How many do I see? 1, 2, 3. From there, we go to 6.5. From there, we go to 7. 1, 2, 3 sevens. From there, we go to 7.5. From there, we go to 8. There's 3 of them. So we got 4, 5, 6, 7, 8, 9, 10, 11, 12 data. All right. All right, I'll give you a head start. Tell you what to do next. What do we do next? All right. McShay, what do we do next? The mean, that is correct. All right, calculators. Once again, no Chromebooks, right? I said no Chromebooks, Sean, right? Okay, good. And Sean's going to give us the sum of those numbers since he's already on top of it, please. 8 plus 8 plus 8 plus 7.5 plus 7 plus 7 plus 7 plus 6.5 plus 6 plus 6 plus 6 plus 6.42 approximately. Looks about right. So what was the sum? 77 divided by 12. Okay. What do we do next? Tell your neighbor. And we have Aubrey's going to enlighten us. What do we do next with that number? Subtract it from the numbers? Yeah, subtract 6.42 to all these numbers. All right, so 0 minus 6.42 is negative 6.42. We put that in parentheses. Then we got 6 minus 6.42 is negative 0.42 in parentheses 3 times. From there we got 6.5 minus 6.42. That gives us 0.08. We square that. Then we got 7 minus 6.42. That is 0.58. 3 times. 0.58. 0.58. Next, 7.5 minus 6.42. Oh, that one's that. Is 1.08. And then 8 minus 6.42 is 1.58 3 times. All right, square these. And I'm going to wait for you guys to give me numbers. Give you some time. Square all these. All right, 6.42 squared. Fernanda, what'd you get? 41.2? 41.2. Thank you. What is 0.42 squared? 0.42 squared. Pass someone, Fernanda? Anessa? 0.176. And we're going to write that 3 times. 0.176. 0.176. We're squaring these numbers. Next, 0.8 squared. Pass someone, Vanessa. Point 16. Point 16. 0.0064. More like it. Very good. Next, 0.58 squared. Pass them on. 0.3364. 3 times. Now I need 1.08 squared. Pass someone. Oh, let's pass it to Lolly, since 1.08 squared. 1.16, and then we need 1.58 squared 3 times. Pass someone? George, 1.58 squared. 2.49, 2.49, 2.49, and we know what to do with that, right? Find the mean again. Add those numbers, divide by 12. Somebody give me the mean approximately. George, pass someone. All right. 41.2, 0.176, 0.176, 0.176, 0.0064, 0.3364, 0.3364, 0.3364, 1.16, 2.49, 2.49, and then divided by 12. 4.2 approximately. Hands, if you got that? Bless you. And then last but not least, we need the sigma or the standard deviation. We take the square root. Who's got that? 2 point what? 2.0? 0.49? 2.049. All right. Let's finish this. Here we go. Bell curve. Our mean, or original mean, was 6.42. And that's the average score of the block parties. If we go one standard deviation up, that means 6.42, we add this, so that gives us 8.46. I'll leave it as 4.6. But if we go one standard deviation down, we subtract from 642 the 2.04, so that gives us 4.38. So what does that mean, Mr. Q? That the norm for the pop parte was from what? 438 all the way to what? 8.46. That's our norm. So look at the scores before we leave. Look at the scores. This is the norm from here to here. Tell your neighbor what you can conclude from all those scores. Conclusion. Nick, pass them one. Sean, conclusion. One student did not meet the norm. Hands if you see that. What was that person? This one with a 0. From 1 to 5, how comfortable are you with that? Yeah, 5, 4, 5, 4. That's going to be your home plate tonight. You have 2 of them. That looks like this. All right, make sure you have the code written down for that to do at home. Those of you following on YouTube, make sure get some practice in. There's the code. See you guys next time. Peace.